Okay, so we're going to solve exponential and logarithmic equations in this video. Let's go over our first rule. It's pretty easy. If we have 3 to the x equals 3 to the 5th, what do you think x has to equal over here? Well, you guessed it. If x equals 5, then this is true. Okay, so then we have 3 to the 5th equals 3 to the 5th, which is common sense. Okay, so basically what that means is that if we have the same base and they are equal to each other, that must mean that my exponents are also equal to each other. Okay, so let's go over an example of this. We have 4 to the x power equals 1/2 times x to the minus 3 power. Okay, so our first step is that we want to rewrite 4 and 1/2 in the same base. Okay, well, we can write both of these in base 2. 4 is 2 squared. 1/2, and then this is to the x power. 1/2 is the same thing as 2 to the negative 1 power. Remember, this takes the reciprocal. This is to the x minus 3 power. Now, properties of exponents here, this turns into 2 to the 2x. And this turns into negative x plus 3. This negative switches this sign and switches this sign. So this is going to be 2 to the negative x plus 3. Now look, we have the same base, same base. That must mean that my exponent here and my exponent here are equal to each other. And this is a quite simple pre-algebra problem here. We have 2x equals negative x plus 3. I'm going to add x to both sides. This gets me 3x equals 3. Divide both sides by 3. And what do I get as my x? My x is equal to 1. Easy enough. All we have to do is get these at the same base, and then the exponents equal each other. Now the same concept for logarithms. Okay, if we have log, here's an example, log base 2 of x equals log base 2 of 7. What do you think x has to equal? Well, of course, x has to equal 7, so that log base 2 of 7 is equal to log base 2 of 7. Okay, let's go over an example of this. Okay, we have log base 5 of 4x minus 7 equals log base 5 of x plus 5. Okay, if you notice here, we have the log of the same base, so that means that what we're taking the log of must equal each other. 4x minus 7 equals x plus 5. And then again, it's a simple algebra problem. We can subtract x from both sides. I get 3x minus 7 equals 5. Add 7 to both sides. Get 3x equals 12. Divide both sides by 3, and I get x equals 4. Okay, so now we have another problem here. We have 4 to the x equals 11. So 4 to the what power equals 11? Well, it's tough to say. We know it's going to be in between 1 and 2, because 4 to the first is 1, 4 squared is 16, 11 is in between those two. But what we can do is, I need to get this out of the exponent. So if I take log base 4 of both sides, we learned earlier that these will be inverses of each other, and they will cancel out. Okay, so this is going to be log base 4 of this. And then let me rewrite it down here. So log base 4 of 4 to the x equals log base 4 of 11. It's very similar. Whatever you do to the left, you have to do to the right side. And then these are inverses of each other, so I'm just left with x equals log base 4 of 11. Now we can use the change of base formula, which we learned a day or two ago. This is written as log 11 over log 4. Use your calculator here. So here's the change of base, then you use your calculator here, you get x equals 1.73. Remember that you just hit log 11. Okay, you write your answer. So you plug this in your calculator, log of 11. Common log of 11 is 1.042. Common log of 4 is 0.062. Plug that in your calculator to get 1.73. Okay, so now let's do the other way when we have to exponentiate each side of an equation. So we want to solve log base 4 of 5x minus 1, and that equals 3. Okay, see how this x is inside this logarithm? We want to get it out of there. So how do we cancel out log base 4? Well, if we base it, base 4, and we rate this in the in the exponent, these will end up canceling each other out. So we have to do the same thing on this side. So 4 raised to the log base 4, these cancel out. I'm left with 5x minus 1 equals 4 cubed is 64. Add 1 to both sides, you get 5x equals 65. Divide both sides by 5, and you get x equals 13. I really hope the Titans draft Marcus Mariota.